Hi everyone, so this is a video, I guess, for everything that's in Unit 1.3.2, and one of the trickier ones is everything to do with von Neumann architecture, to do with buses, to do with fetch execute cycle, registers, a lot of tricky theory to really understand or memorise if you are closer to the exam. So what I would recommend is reading through the question with me, maybe pausing it, having a think about your answers before it. But ultimately, these comments here, these are the important notes that you need to have in your notebook and need to be revising. So they're really important. So I would be pausing often and adding to notes. So let's get cracking. Hopefully straightforward enough. Remember the address bus, unidirectional, data bus, bidirectional, control bus is in command of everything. So let's look at things that give it away. So address bus, if we look at the descriptions here, unidirectional, I know right away that is the address bus. Looking for bidirectional, there's the giveaway for the data bus. And that leaves us with the control bus, carries signals used to coordinate the computer's activities, all the things to do with the fetch execute cycle. I know this is really, really messy. Try to be very clear when you answer that in the exam. Additional things that you could look up are what are some of those signals. For example, read is one of the lines that can be activated on the control bus. Okay, so next up, tricky one, but it's easier than it can be asked because you need to be able to describe this as well. So we've got 7 stages in von Neumann fetch execute cycle. The way that I tried to remember it is step 1, that we need to break it down, get it, do it. So we know that execute is going to be something that happens last. So even if you want to look and figure out what happens last, that can be a good start. So if I look for something that says that we need to decode it and execute it, there we go, decoded, executed straight away. We've got 1, 2, 3, 4, 5, 6, 7 steps here, so I know that is the last step. Now there's a little bit of flexibility in terms of one of the answers here, depending on it's irrelevant the order you do it in. So in order to get it, we need to know where it is. So who do we tell where it is? We need the MAR to be told the address that has to be accessed, that we want to access it, and that address we want to access is what's in the program counter. So the program counter keeps track of the address that we want to access and carry out that instruction. So let's look for memory address register next. There we go, we've got memory address register here. Let's see what else. Any other memory address register? We've got memory address register here. So there's a few potential options. So let's get a read. Instruction is then copied from memory location contained in MAR. So that's copying, it's not quite activated yet. Address contained in the PC is copied to the memory address register via the address bus. And the address part of the instruction is NA is placed in the MAR, memory address register. So it's going to be this one. We need to get the address that we want to access into the memory address register, so we know where to copy this data that's in the RAM into our register. So we need to get to the MDR basically. Okay, so next step we know the address. The control unit activates the read line to make this happen, and then it's this top one here, that a copy of the contents, because it's not the original, it's a copy that's placed onto the data bus and transferred into the MDR via the data bus. Next one, you could have anything, not anything, I'll explain what I mean in a second. I think I actually answered that last part there. The entire instruction is copied from the MDR and placed in the current instruction register. That's what happens next. so that it's there ready to be used. And the next part, number 5 and 6, could be either way around here. The value in the program counter is incremented, so it points to the next instruction to be fetched. That one, as long as you have carried out step 2, we could have done that pretty much at any time, and then the rest need to be in the same order. So we could say to number 5, that means the next time we carry out this fetch, that the next instruction will be fetched. And then this next part is relevant to what we've got. So the instruction that's been fetched, the address part of it is going to be placed into the memory address register. That, for example, if the instruction was to store something in memory, or if it was to add values, it would tell it where to save the result, because remember, the von Neumann architecture, the data that's been fetched is data and instructions in one, so it's the data that wants to carry out instructions with. Right, quite tricky, and again, very worthwhile reviewing that and being able to write a very good description of it, possibly even more succinct than that one there. What have we got next? So 2 features of von Neumann architecture are registers and the use of buses. So there's a lot, and obviously us doing this way is quite straightforward to answer these questions as we've seen the answer. So buses, we had the control bus, which is giving out commands. We have the address bus, and just for extra, we've got also the data bus. So there are 3 buses that we know of. And try and give full names for the registers, but you probably get away with them. So we got the PC, which is the program counter. Need to work on my writing. The MAR, memory address register. I'll be lazy so that I can write in block capitals. The MDR, memory data register. Again, those were given away a second ago. So we've got the current instruction register / instruction register, and the accumulator. There's a lot more actually if you do any reading. Please give full names. I'm only not doing it because my handwriting is horrendous. Probably more binary here. Oh well, actually it's problem solving based on binary, these questions anyway. So it's telling us the contents of memory location, this one. Now this is where you should get highlighter pens. So the memory location obviously corresponds to the addresses. So if we get a nice highlighter pen out here and look for 10001, it's this one right here. Let's get a bit of pen size. There we go. So it's this register there, and they're to be read. Show the contents of the memory address register and memory data register during this operation. Now that's quite a cheeky one, and some people get confused as to why the MAR is literally what's on the page now. It's literally what they gave us for the answer, and it's because that's the location in memory that we want to access right here. So the contents from that location are read, so we get 0, 1, 0, 1, 0, 0, 0, 1, and this is quite good actually for visualizing how that fetch execute cycle works. This could translate to an instruction that could be decoded and executed again, because obviously that fetch execute cycle is just a continuous process. But this one here is problem solving. You've got to know that the address is the memory address register, and then the data is the contents. You see they've used some different to say the same thing. Similarly again, let's just do this one quick. So the value 001 is written into the memory location. Show the contents of the MAR and the MDR during this operation. So we actually don't need to look at this part here. We just need to take memory location being the MAR, which is 10001110, which I got from here. And let's just change the pen. The MDR is the data we want to write, which is 01111001. Straightforward. Okay, let's see. Show any changes to the computer memory following the read and write operation. The contents of this memory location. So if this was me in my exam, I would be highlighting that and thinking 100001. It's there, are to be read. the value 0, 1, 1, 1001 is written to this memory location, which is this one. Show any changes to the computer memory. So this one, there's no change because it's just a read operation, but write operations like this one are going to change. So the final answer you would want to be writing down for this one is that value. It's got to go in there because we're writing that into memory. It's the same question really, just asked slightly differently. Again, 3 registers used in computers, already covered that one. Control unit, what's the function of the control unit? So we've looked at that, I guess, slightly. So it's controls, it depends how you write it, controls other parts of the processor, sending signals. I'm going to run out of space here. Sending signals of what to do, e.g. read. I always love to give examples in mind. So that's 1 mark. I mean, that's not great for all the marks. Let me zoom out so I can write some more. Interprets instructions. Obviously, it's in control of all the memory as well. So all the memory, processor, and inputs. And output devices. I guess we'll just go with outputs. So it's, I guess it's really, I mean, it's in the name. It controls the operation of the computer system, or the processor rather. It's constantly fetching and interpreting instructions. You've got to use instructions for this actually. We're looking for that key terminology to be used. Instructions, constantly happening in memory. That's a tough one. That's a very tough question worth a review. Let's see, contents are read. Let's just skip that one because it's the same as previous one, same as previous one. Have a little bash at it. Come and talk to me if you're unsure of the answer on this one. 3 registers used in computers already covered. Okay, here's a good one. Different from the ones we looked at. And I think I've actually already answered this, to be perfectly honest. So the CPU goes through a cycle that's got 3 main stages. Some people write input, process, output. Now, I like your thinking for that, but that's incorrect. That's to do with how we plan, I guess, the basics of our algorithms for coding. So we're going to fetch, it was already covered, and we know it's execute. But some people always forget that we need to decode that instruction. Now, that is because instructions usually have 2 pieces to them, the piece of data. So it has the part that would be correspond to the instruction, and then the data part to do with that particular instruction. Like, for example, add 3. That's an instruction that tells to carry out the addition part, and there's the data that we want to carry it out on. Obviously, it's not as simple as that, but that's kind of how it works at a basic level. Okay, tough one. Well, not necessarily tough. We've already got it here. So let's go through the different ones we can have. So we know we can have address bus, the data bus, and the control bus. We already answered the control bus ones. I guess for each of those things that we want to do is talk about the data. So that is unidirectional, data bus is bidirectional, and the control bus can be both, either or. So that the things we want to be here is describing it, because look at 6 mark questions, the thing you want to be talking about here. So we want 1 mark really for identifying the bus, and then 2 purposes. So address bus, it carries the addresses to access of data to be fetched or written, because it also writes data, or the control unit also writes data into memory as well. Data bus, so obviously to say it's bi-directional, and it carries data to be processed, i.e. it needs to be decoded and executed. And then we cover the control bus there. It carries the transport, it carries signals to the other parts of the processor. I guess it's worth covering those right now. So we have lots of different ones, I believe, or at least I hope in class. We talked about interrupts. We've also talked about a similar different type, which are non-maskable. The clock is one of those lines, as is the read, write and reset. Now those are all instructions that can be carried out by the control bus. Again, this is an important one to make sure you understand these really well, because if that question comes up in the exam, it's tricky. But then again, if we look at the first question we did, it was quite straightforward to pick them out when they were listed there already. 3 different buses that's used during the fetch execute cycle. Let's not write that one again, we've covered it already. Here we go, good one for fleshing out our notes. Now my technique for these in the exams has always been to pick the ones that I definitely know first. So if I look down the description side first, let's have a look here and say used to connect together the internal components of the CPU. It's been a while since we studied that. Let me leave it. Used to carry out calculations on data. Well, I'm very confident in that one being the arithmetic logic unit, because that's the function of the ALU, right? Let's look down the list again. Used to temporarily hold data instructions during processing. Now I'm going to put an asterisk, or let's put it green because that's the colour I've got, because that, if I look down, this is the one that I sometimes just jump to conclusions and say, oh, it's this one. So let's leave that one to the second. Used to allow interaction with the computer system. So looking down the components at the side there, I was immediately thinking, is it HCI? I hope it's not on pen. Is it HCI? Something to do with the human computer interface. So when I see input and output, well, that's what allows me to interact with the computer system. What else do we have? Next, used to manage the flow of data through the CPU. Well, we just talked about how that's one of the jobs of the control unit. So again, if I was being a smart student here, I would be adding this to my notes on what I could write for an explanation of what the control unit does. Now, again, you don't have to, just if you're good at visualising this, you don't have to, but I like to just think, okay, what ones have I not talked about now? I have, what have I missed? I've missed the registers, I have missed buses, and I've missed immediate access store. So right away, that narrows my field down. Used to connect together the internal components of the CPU. Nice, easy peasy. That is the buses. Now that leaves the 2 difficult ones, unfortunately. We've got registers and immediate access storage. Now, the way I remember it is, think of a good terminology here. The registers are the ones that's used during the processing, because that's what's been happened. The immediate access store is a misleading name, but that holds data and instructions before they are processed. It's worth a little bit of reading into that over. Again, I say that a lot for these notes. But again, it's the technique here. For goodness sake, please always draw lines to some of them. At least guess these if you're unsure. As I've had students in the past leave these blank. Again, add things to your notes. Look for the ones that you know first. Use pencil. And then it's very easy to change it, because quite often people make an absolute mess of it and lose marks because you can't tell where the arrows go. Says me, very cheap by notes. Well, we already had that. Looks horrible there. Right, let's see. Writes 4 answers in her computer science examination. So some of this is only slightly relevant. It could be in a couple of units here, so don't be concerned if you've not studied this yet. So it's a signal. When the signal is received, it tells the OS that an event has occurred. We talked about that earlier on. That is an interrupt. It takes source code written in high-level languages, translating it into machine code, and translates the whole of the source code at once. So that's the giveaway, because that I thought for a second it's an interpreter. A translator, but it's looking more specifically at which one it is. So a compiler translates the whole source code into machine code at once. This is why this question's been put in here. The CPU that carries out calculations, we already had that one, and it's the ALU. Try to put the full names just to show your intelligence, but you should get it for that. And again, this one we might not have covered if you're watching this at a different time in class. When you detect an error and a signal sent to say retransmit it, and again, that's not because you do it, it's automatic, so it's an automatic repeat request, ARQ. Again, full names for that is really helpful. Let's see what else we have. Good, so let's see if we can do this one a bit easier. There we go, immediate access storage. There we go, whilst they are waiting to be processed, easy peasy. Register holds data temporarily, is currently being used, and let's see, so we want that when they're being processed. There we go. This one's talking specifically about once being used in a calculation, so let's come back to that one. Manages the flow of data and interaction between the components in the processor. There we go, control unit. Let's see, holds data temporarily that's been used in a calculation. Let's see, I'm thinking about the ALU here, so let's not go yet, and I'll tell you why. If you were thinking ALU, you're right to think about the ALU, but then when you look at this one, carries out calculations on data. That's the ALU. This one is the very specific register that's used for the accumulator, and then the bus pathway for transmitting data and instructions. Now, I didn't do that one the way I say I normally do, where I look for things that I definitely know are correct first, and that was very lazy. But take a minute to do those ones. 5 marks, really important, and it should take you at least 5 minutes really to do it, as much as it probably doesn't. And the reason it's 5 marks, even though there's 6 descriptions, is if you get 1 or 2 wrong, you lose the mark. So you've got to get like 6 to get 5 marks on that part of the board. Right, let's see, filling in stuff. This is a good one again for improving your notes. The central processing unit, some things the data and instructions needed. So the word that describes that is the whole, that's it, gets them. So which word up here is to do with gets? There we go, fetches. So fetches the data and instructions needed and stores them in the, what have we got? Immediate access storage. I'll just write IAS. That's good that that's come up a few times, because it obviously doesn't store them directly in the registers because they are currently being used to wait to be processed. There we go, there's the giveaway. I knew it was that one. The something holds the address of the next instruction. So that's the program counter. Now, you might be thinking, oh, well, the memory address does that. No, the memory address holds the address of where it is. The PC, the program counter, keeps track of what instruction it is. The address is sent then to the MAR, where it's stored, rather than the actual location, not location, we're talking sharp, the address we want to put to the MAR. The data from this is sent to, the address is sent to the MAR. The data from this, let's see, is sent to the, the data from this address, I need to read that more carefully. So obviously the data is sent to the MDR. The instruction can then be decoded, and looking down, obviously I knew it was going to be executed, just checking, sure it's there, executed. Any calculations that are carried out in the data are done by the ALU. And during calculations, data is temporarily held in a register called the accumulator. Right. Very straightforward, I hope, after seeing some of the earlier questions. Let's see, explain how an instruction is fetched based on the von Neumann model. So that's basically us explaining the answer we did earlier. So we've got the PC holds the current instruction. I'll just be lazy when I write this. That's then sent to MAR. The control unit activates read line, or sends the instruction to say carry out the read instruction. You could say then data transferred to MDR via data bus. What else? We can then say the instruction is decoded and executed. The PC is incremented, i.e. added one on, before the next instruction is carried out. So 6 marks, we've got 6. PC holds current instruction. The address from that program counter is sent to the MER. The control unit activates the read line sent to the MER via the address bus. We should probably put in here, be specific. Even though it might seem obvious, let's get it in there. Activate the read line. The instruction, maybe we should actually not say the data, so let's just say the instruction that's being fetched, or data, and data is related via the data bus. The instruction is decoded and executed, the program counter is incremented. We could also talk there actually about how that instruction that's fetched is sent then into the current instruction register as well. Should have rewritten that one. It's a bit of a mess, so try and work your way through it, take the notes. So the program counter contains 10010, so if we look for that register there, shouldn't have done that, that was silly. Let's undo that. 110, that was silly, that one. So we've got that address register there. Okay, basically write that there. We've got, I just did the wrong answer for that one. State the data placed in the memory address register. Oh, I did. I was just too speedy for that one. I did answer the next question. So that one, sorry, I hope you spotted that actually. I'd be interested to know if anyone comes and says to me. So it's 00100010. Important that you put it as, well, not necessarily 8 bits. Basically just write that there. Right, I got it wrong, sorry. This one's already, just in case you're keen. State the data that's pressed in the memory data register. Trying to be too quick. This one is the actual question I just answered. There's the address, what's going in the MDR, that's the one that's in the content. So 11110001. Sorry, we're all human. Let's see, describe the program concept when applied to von Neumann model. This is a good one to cover actually, it's quite tricky. Program and the instructions. I'm just going to write a big I and with a smiley face and a love heart for that, so you know it's instructions. Stored on secondary storage. Now that brings up secondary storage. Why is it not in RAM? Well, all of your programs that you have on your computer, or the files that you have on your computer, are not stored in RAM until they are in use. So then this data and the instructions of which that's part of are moved to memory, i.e. what memory? Think about it. RAM. Okay, primary memory. Now the reason I put that is because they're both the same. They're stored in the same memory space. Now if you remember doing Little Man Computer, we saw that being happened. The instructions are fetched and executed one at a time. What else can we say there? And for this part, data moved to main memory. Instructions are fetched and executed. We probably should have put in there instructions are fetched to registers, i.e. like the current instruction register, for example. Just to give a wee example there, so there goes 5 marks worth there. Describe the role of program counter. We've already spoke about it. 2 marks is a bit tricky because people will just say basic. So it holds address of next instruction that will be fetched. You could even say in there increments each time an instruction is fetched. Hopefully you can read that writing. So nice, straightforward. Describe the role of the memory data register. So saves data or the instruction. There we go. Don't write this in exam. Write instruction. That is being used, I guess. Being used. Fetched from the address given by MAR. Easy peasy. Nice. These are the best ones. You can fill it in. Okay, so the CPU processes. What have we got here? We've got data and instructions. Oh, okay. So data and instructions. This is perfect to add to your note. An instruction is something from something is fetched from. Fetch data instructions fetch from what we want? We want it's going to come from RAM, not ROM, from RAM into the CPU, where it is then decoded or executed. What we got? Once it's taken place, then it's then decoded. Once this is taking place, the instruction is then executed. Really bad handwriting there. The pen size smaller for writing. Let's try that. And a computer uses the von Neumann model. It's third program concept. So the program. Did we cover this one? No, I'm confused. Program and instructions. I think we did. Yeah, we did. Little man computer. Look at it. Program instructions saved and memory. Instructions are fetched and executed one after another. Again, get stuff like that in your notes if you can read my handwriting. Good one. I don't think we've covered this one yet. So ALU carries out calculations, makes decisions. Batteries on it, based on logic. Slow my handwriting down. Uses accumulator to temporarily, well, bad handwriting, store values and data, values during calculations. Yeah, so makes decisions based on logic, i.e. logical operations. Logical ops and mathematical ops. So calculations, logical decisions, logical operations, uses accumulator to store values during the calculations. It's a tough 4 marker actually. Explain how an instruction is sent. Alright, we already covered that one. PC holds the address of the instruction. The PC address is sent to the memory address register using the address bus. The memory address points to the location where the memory or the instructions to be stored. That instruction is sent to the MDR using the data bus. That instruction is then sent into the current instruction register, and then the control unit is managing that full process there, sending the signals out. Again, that one, don't go into, if that comes up actually, it's not talking about how it's executed there, it's talking about how it's fetched. So obviously you need to talk about 3 things. So in all of these really you need to talk about the address bus, the data bus, and obviously the registers, which is the MAR, the MDR, and then the control bus, because they're all involved in its control signals. Try and get into your mindset of talking about all of these, and even if you need to use more space to be more detailed, great. let's see, identify 4 other components in the von Neumann model of the computer system. Oh my goodness, we've written so many of them. You could talk about inputs, output devices. We could talk about arithmetic logic unit, memory address register, MDR, accumulator. Literally any of the things we've talked about. The same question as the previous one. Yeah. In the process of this video, let's see components of the computer system. Same one again as we just covered. It was 4 versus 2. So any of the registers: accumulator, CIR. Data bus, MDR, all of these things, all the terminology, basically the terminology. Nice, easy one here. So let's do this nice way. So let me see, increments to point to the address of the next instruction to be fetched. Well, I'm confident on that one being the program counter. So let's get that drawn. Straightforward. Let's see, holds the result of a calculation. It is located within the ALU. Well, I'm quite confident that that's the accumulator. Carries signals to synchronise the fetch execute cycle. There's a very good one. So there's that signal. So I know that that's going to be the control bus, just based on that signals. Temporary storage between the CPU and the primary memory. Well, that applies to that one. That's a cheeky one, because lots of the registers are temporary storage between the two of them. Let's see, state 2 buses other than the control bus using the von Neumann system. Alright, great. We've already covered that one as well. Nice, straightforward. There we go. 1.32 covered very, really well with great handwriting. I'm sure you'll agree.